Vanakkam. Today we are going to see envelopes in differential calculus. Envelopes. Envelopes. Okay. So what is the definition of envelopes? So a curve which touches each member of a family of curves tangentially. So it's called envelope. So we'll be given a family of curves and we are going to find the envelope of a curve. For example, if we have a family of curves uh, x minus a the whole square plus y square equal to some radius 1, let me take. So it's clear, you know, that this is the family of circles, because the general equation of the family of circles is x minus a the whole square plus y minus b the whole square equal to r square, where a comma b is the center and r is the radius. So here in this family of, in our example, this represents the center a comma 0. This is the center. Okay, this is the center and the radius is 1. So what will be the envelope of this family? That is what we have to find. So if you draw this family, okay, let me take y axis, x axis. Okay, so center a comma 0 means it lies on x axis. Since y equal to 0, the center lies on x axis. So let me take the center, this point 1 comma 0, this is 2 comma 0, this is 3 comma 0, or any point you can take. Okay, so here if you see, the radius of the circle is 1. Therefore the circle will be like this. So it's somewhat difficult to draw, understand. Okay, this is a center with radius 1. Similarly, if you consider this as a center, you will get a circle like this. And if you are having this as center, this as center, you will get a circle like this. So similarly, you will get a family of circles. For example, this, if you consider this as a center, you will get, since the radius is 1, you will get a circle. Okay, so you will get a family of curves like this. In the negative side also, if you take minus 1 comma 0 as center, you will get a circle like this. Okay, so if you are getting a 0, you will get a circle like this. Center is 0 comma 0 with radius 1. So what is the envelope of this family of circles? So clearly, if you see, we can, what is the definition? A curve which touches each member of the family of curves tangentially. Therefore, so I am touching each member of the family of curves tangentially. So it will go on like this. So similarly I am getting another one more curve like this. It touches tangentially, and clearly these two are the straight lines. So these two are the envelope of this family of circles. Therefore, uh, the envelope of this family of circles, that is x minus a the whole square plus y square equal to 1, is the straight line. What will be the equation of the straight line? See here, what will be the equation of the straight line? Here, if you take any value in the straight line, the y value is constant, that is y is 1 and x is y is 1 and x is a variable. So this is the straight line y equal to 1, and this straight line, the name of this straight line is y equal to minus 1. Clear? So let me prove this theoretically. We are going to find, or we are going to prove, the envelope of this family of circles x minus a the whole square plus y square equal to 1 is the straight line y equal to plus or minus 1. So how we are going to find the envelope? What are the steps? So the first step is here, if you see this family of curves here, this a is the parameter. Okay, this a is the parameter. Okay, so to find the envelope, the first step is you have to differentiate the given family of curves. Let me consider the family of curves as x comma y comma a equal to 0 with respect to the parameter a partially. That is, you have to differentiate partially with respect to a. So if I am differentiating this x minus a, that is x minus a the whole square plus y square, let me consider this as equation number 1. So differentiate equation number 1 partially with respect to the parameter a. So we'll get 2 times x minus a. When you differentiate inside the bracket, you'll get differentiation of x with respect to a is 0 and differentiation of a with respect to a is 1 plus y square is constant with respect to a, therefore it will be 0 equal to 0. Therefore I am getting minus 2 times x minus a equal to 0. Therefore I am getting x is equal to a. So when we apply this, then the next step is so what we got partially, and find the value of the parameter a with respect to x or y. Let me consider this as the first step. So I find that a with respect to xy, here a equal to x. Now substitute this a equal to x, substitute this in equation number 1. We will get, what is equation number 1? X minus a the whole square. When you replace x by a, we will get a minus a the whole square plus y square equal to 1. Therefore y square equal to 1, and we are getting y equal to plus or minus 1. This will be this is the R. This is the envelope of x minus a the whole square plus y square equal to 1. So here the steps we followed are, first of all we have to differentiate the given equation partially with respect to the parameter, and we have to find the parameter, and when you substitute the parameter in the equation you will get the envelope. This is the way we are going to find out. And I also see that here I got theoretically y equal to plus or minus 1, but when I already shown that graphically what will be the envelope of that family of circles also, that is y equal to 1 and y equal to minus 1. So I think it's very clear. for you to find the envelope. This is the first example. So let me see one more example. uh, Second one, find the envelope of family of straight lines, family of straight lines, uh, y equal to mx plus amq, where m is the parameter. So let me find the envelope of the family of straight lines. What is given? Y, the curve is y equal to mx plus amq. Let me consider this as equation 1. It is given that m is the parameter. So differentiate as per the step. The first step is you have to differentiate the given curves, family of curves, with respect to the parameter. Here the parameter is m, with respect to m. Therefore that is partial differentiation. Okay, partially. Therefore you get 0 is equal to x plus 3am square. Therefore I am getting 3am square equal to minus x, and m square equal to minus x by 3a. So m is equal to minus x by 3a whole power 1 by 2. So now we have to substitute this value of m in the equation 1. We will get y equal to minus x by 3a whole power 1 by 2 into x plus a into minus x by 3a whole power 3 by 2. Now we are taking this minus x by 3a whole power 1 by 2 as common. We will get 1 into x. Okay, let me write this as x plus a into minus x by 3a. Clear? Because 3 by 2 can be written as 1 plus 1 by 2. I am taking this 1 by 2 as common, therefore inside there will be power 1. So this a and a get cancelled, therefore we are getting minus x by 3a whole power 1 by 2 into x minus x by 3. So again when we simplify this, you will get minus x by 3a whole power 1 by 2. 3x minus x is 2x by 3. So here we are having y. So when we square both sides, you will get y square, squaring both sides. Both sides, you will get y square equal to minus x by 3a into 4x square by 9. So this is the envelope, of y is equal to mx plus a m. This is the question. Okay, this is the answer for this problem. So this is a very simple example for finding the envelope. Now we are going to see the third problem. Find the envelope of the family of parabolas x by a whole power 1 by 2 plus y by b raised to 1 by 2 equal to 1 under the condition ab equal to c square, and also the another condition a plus b equal to c. So now given the family of parabolas, what is the name? X by a whole power 1 by 2 plus y by b whole power 1 by 2 equal to 1. That is root x by root a plus root y by root b equal to 1. Now let me consider this as equation number 1, and our target is here a and b are the um, parameters, so we have to eliminate a and b, and I am going to solve the first one with respect to the condition ab equal to c square. So differentiate equation number 1 partially with respect to a. Therefore, with respect to a means root x is constant, and the differentiation of 1 by root a, that is 1 by root a means a power minus 1 by 2. Then what will be the differentiation? Differentiation of a power minus 1 by 2 is minus 1 by 2 a power minus 3 by 2. Okay. Therefore, the differentiation of 1 by root a is minus 1 by 2 a power minus 3 by 2 plus, okay, root y. Since a and b are independent variables, the partial differentiation with respect to a of root b is minus 1 by 2 b power minus 3 by 2 into db by dA, which is equal to the differentiation of constant is 0. Okay. Therefore, you see here, here I am using dB by dA. You can also use dou b by dou a. Since it is partial differentiation, you can also use dou b by dou a. So from this I am getting root y minus root y by 2 b power minus 3 by 2 dB by dA equal to root x by 2 a power minus 3 by 2. So these 2 and 2 will get cancelled. Therefore, we are getting dB by dA equal to root x by root y minus root x by root y a power minus 3 by 2 divided by b power minus 3 by 2. This is what dV by dA. Now, with respect to the condition AB equal to C square. So first of all, I am going to find the envelope with respect to the condition AB equal to C square. Let me consider this as equation number 2 and differentiate equation number 2 partially with respect to A. What will you get? So here we have to use the product rule, A into dB by dA plus B into 1 equal to 0, because C is constant 0. Therefore, in this equation we are getting A into dB by dA equal to minus B. Therefore, dB by dA equal to minus B by A. Now, if you see, if we compare these two equations, let me consider this as A and B, equation number A and equation B. So by A and B, the left hand side dB by dA is there. Therefore, automatically the right hand side, both the right hand sides are common, are equal. Therefore, minus B by A equal to minus root x by root y, a power minus 3 by 2 divided by b power minus 3 by 2. Okay. Therefore, we can write this as minus root x by root y b power 3 by 2 divided by a power 3 by 2. Now, which is equal to minus root x by root y. We can write b power 3 by 2 as b root b divided by a root a. Here we are having minus b by a. See, this minus and minus will get cancelled. Therefore, also this b and b, a and a will get cancelled. Therefore, we are having 1 is equal to root x by root y into root b by root a. Therefore, we can write this as root y by root b equal to root x by root a by cross multiplication. So, by the condition of equality, we can write this as root y by root b divided by 1, root x by root a divided by 1, and we can write this as root y by root b plus root x by root a divided by 2, which is same by definition of equality. Now we have this root of y by b plus root of x by a, that is equation number 1, which is equal to 1. Therefore, the numerator will become 1 divided by 2. So this is what the question, root x by root a plus root y by root b, which is equal to 1. That is equation number 1. Therefore, this will become 1 by 2. Now, by comparing the first and last, we are getting root y by root b equal to 1 by 2. Therefore, b is equal to 2 root y. Root b is equal to 2 root y. Therefore, by squaring both sides, we will get b is equal to 4y. 4y. Similarly, we will get a is equal to 4x. By comparing root of root x by root a equal to 1 by 2, we will get this. So we got the value of a and b. So what is given? The second condition is ab equal to c square. Substitute a and b in equation number 2. That is ab equal to c square. We will get 4x into 4y equal to c square. Therefore, 16xy equal to c square, which is the envelope of root x by root a plus root y by root b equal to 1 with respect to the condition, ab equal to c square. So this is the answer. Okay, this is the answer. Now the second condition is a plus b equal to c. All right, this is the second condition in this problem. It is given that a plus b equal to c. So this is what the second problem. Okay, a plus b equal to c. Now let me consider this as equation number 3. So differentiate equation number 3 partially with respect to a. We will get 1 plus db by dA equal to constant is 0. Therefore, dB by dA equal to minus 1. So let me consider this as equation C by comparing A and C. What is A? A is equal to dB by dA equal to minus root x by root y, a power minus 3 by 2 by b power minus 3 by 2. So minus 1 is equal to minus root x by root y, a power 3 by 2 minus 3 by 2 divided by b power minus 3 by 2. Alright, minus root x by root y, a power minus 3 by 2 divided by b power minus 3 by 2. Now this minus and minus we can cancel. So we are getting root y divided by or root y into b power minus 3 by 2 equal to root x into a power minus 3 by 2. That is now, so root y by b root b equal to root x by a root a. So I can write this as uh, root y by root b root y by root b divided by b is equal to root x by root a divided by a. By the property of equality, we can write this as root y by root b plus root x by root a divided by a plus b. We have by equation number 1, this is 1. By equation number 1, the numerator is 1, and by equation number 3, a plus b equal to c. This is by equation number 3. Therefore, I am getting the relation root y. So root y by root b root b equal to 1 by c. Therefore, by cross multiplication, b root b equal to c root y. Similarly, you will get root x by a root a equal to 1 by c. Therefore, a root a equal to c into root x. If you see, by squaring both sides, you will get or by squaring both sides, okay, we will get b cube equal to c square y. Similarly, here you will get a cube equal to c square x. So by squaring both sides. So by squaring means b will become b square, root b the whole square is b square into b cube. C square root y square is y. So b cube equal to c square y and a cube equal to c square x. But we have the relation. Then what is b? B is equal to c square y whole power 1 by 3, and a is equal to c square x whole power 1 by 3. But we have the relation a plus b equal to c. Therefore, c square x the whole power 1 by 3 plus c square y the whole power 1 by 3 equal to c. Now, by separating this, we will get c power 2 by 3 x power 1 by 3 plus c power 2 by 3 x y power 1 by 3 equal to c. So taking c power 2 by 3 as common, you will get c power 2 by 3 into x power 1 by 3 plus y power 1 by 3 equal to c. Therefore, x power 1 by 3 plus y power 1 by 3 equal to c divided by c power 2 by 3. So which is equal to c power 1 by 3. So x power 1 by 3 plus y power 1 by 3 equal to c power 1 by 3 is the envelope of x by a power 1 by 2 plus y by a power y by b, okay, sorry, y by b power 1 by 2 equal to 1 with respect to the condition a plus b equal to c. So the problem is very simple. Here we are having two parameters, so our target is we have to eliminate this a and b with respect to the given condition. Okay.
integrated a and b by finding a equal to c square x whole power 1 by 3